in this video, we're going to solve this question. This is MATH201. I have this question from one of my students as is assignment for them, which is Open University. So I promise you I'm going to solve it and post it in this channel. Other people can also learn from it. This is a calculus, this is differentiation, and I'm going to solve it one after the other. The first one is what? Saying that what exponential tan s, which is exponential raised to the power of tan s. And we have y is equal to exponential tan x. This is function of a function because exponential is a function and tan is also a function of y. So now what we are going to do is that we have to take note of the what? The formula for function of a function of the calculus. And the formula for function of a function is dy dx. Dy dx is equal to dy du multiplied by du dx. But before I move further, so what you are going to do is this. So take note that when you differentiate, when you have y is equal to exponential s, dy dx, if you want to differentiate exponential, we still have exponential s. Take note of that. And secondly, when you differentiate tan s, when you have y is equal to tan s, dy dx is equal to sec square s. I'm going to show you how you get sec square s when you differentiate what tan s. So, how do you know that what if you differentiate tan s, you're going to have sec square s? Remember in the trigonometric ratio, when you have sine divided by cos, you're going to have tan. Like what I said is that y is equal to tan s. I want to differentiate tan s now. Is it as sine x all over cos s? Which means y is equal to sine s all over what? Cos s. In this case, when there is division between two variables, we are going to use what is called quotient rule. Quotient rule. So the quotient rule will state that what dy dx is equal to v du ds minus u dv ds all over v squared. This is what is called quotient rule. So how can we go about this and solve it to have a sec square s? You have to let this one to be u and let this one to be what v. That is, let your u to be the first one is sine x. Immediately you choose your u, differentiate u with respect to what s, that is du ds, which implies that the u ds is equal to, if you differentiate sine s, you have cos s. So you choose the second one as v is equal to what? Cos s. The v ds is equal to differentiate cos s, you have minus sine s. So if you have to input all these into this formula, we have dy dx. Dy dx equals to v, which is our v, v is what? Cos s, open bracket, du ds, which is cos s again, cos s. Following the formula, this is minus. What is u? U is what? Sine s, open bracket, the v here, that is minus sine x. All over this, what is v? U cos s all squared. So if I impute all the word that is connected, so how to expand the bracket? We now have dy ds is equal to cos s times cos s. You cannot say cos s squared. No, nothing like cos s squared. It's called cos square s. Minus times minus, we have cos. Sin s times sin s, we have sin square s. All over cos square is equal to cos square s. In trigonometric identity 1, sin square s plus cos square s, 1 cos square s plus sin square s, because plus is sin is what intensive. So it's 1 all over cos square s. So now in trigonometric identity, when you have 1 over cos s, 1 over cos s is something as sec s. Then this one carries square, which means that dy dx is 1 over cos is sec. See that the to carry square is going to be sec square s. Which means when you differentiate tan s, we're going to have sec square s. But that's not the question that given to us when we solve this. But it's somehow related to it. That is why I solved this, so that I will confirm that what when you differentiate tan s, you get what? Sec square s. So like I've said, we have y is equal to exponential tan s. So we have to let u to be what? Tan s. Let u to be what? Tan s. Then we are differentiating u with respect to s. That is du dx. du ds is equals to, if you differentiate tan s, then you have sec square s, sec square s, which means that our y is equal to exponential. This one is not tan s, it's not u, because we say let to the tan s, which means now y is equal to exponential u. Then when we differentiate y with respect to u, that is dy du, dy du is equal to the same exponential u. So we have to impute all this into this formula. We have dy divided by the s is equal to dy du is exponential u times du dx, that is sec square s. Then dy ds is equal to exponential, what is u? That is tan s, then what? Sec square s. So this is it. So let me give another example to confirm this. Assuming you have y is equal to let's say you have y is equal to what? Exponential 2s squared plus 4. Exponential 2s squared plus 4. It's still the same step. What you are going to do, you let u to be the power. Let u is equal to 2s squared plus 4. Then du ds, differentiating u with respect to s. When I differentiate 2s squared, say 2 times 2, that is 4, reduce the power by 1, that is 4s. Plus when you differentiate constant term, you have that is 4s only. Which means that our y is still sitting as exponential u, because we have said what? Let 2s squared plus 4 is equal to what? U. Then dy du, that is dy du is equal to exponential u. Therefore,